In these problems, we're going to be solving using the laws of logarithms and exponents. We're going to find the exact value first, which means we're going to solve for x, and then use your calculator to round to 2 decimal places. That's the hundredths place. So for this first one, our property states that we want to get the exponent or logarithm by itself, and right now our exponential is 10 to the x, so it is by itself. So the next thing we do is rewrite the exponent as a logarithm. So we start out with log base 10 of 2 equals x. We have x by itself, so this is the exact value. So then you go to your calculator and you come up with the decimal approximation. So for the decimal approximation, it's log base 10, so all I need to do is hit the LOG button and then 2, and then go. So about 3.0. The 1 is not big enough to bump up, so our approximation is 0.30. If we jump down to letter B, again, the exponential is by itself. So we rewrite it as log base 7 of 21 equals the power. The power is always on the other side. To finish solving for x, I need to get rid of the 3 in front. It's hooked by multiplication, so I divide by 3 to both sides. All right, so my exact answer is this, log base 7 of 21, all divided by 3. There's your exact. Once you get the x by itself, you found the exact. Now for the decimal approximation, all right, that's going to take a little bit more work. Log base 7 of 21. I don't have on this calculator the button that'll allow me to change the base, so I have to do it by hand. So off to the side, think about log over log, and then do 21 over 7. And then get that decimal, and then divide by 3. So you can either use log or ln, it doesn't matter. So I do log 21 divided by log 7. All right, and then go. I get that decimal. Don't round that decimal. I'm just going to write down a few of the digits, 1.5645. 1.5645, and then do dot, 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 meaning it keeps on going, but I'm just too lazy to write it all down. And I don't need to because I have my calculator. It's already on the screen. All I have to do is hit divide by 3. It'll take the answer from above and divide by 3, and it'll put all the decimals in there. So rounding to 2 decimal places, this comes out to about 0.52. All right, for letter C, our exponential is right here, e to the x minus 2. So I have a lot to move out of the way first. So one of the things that I'm going to move first is going to be, I'm going to subtract 7, do addition and subtraction property first. All right, and then from there, get rid of the 3 in front of the exponential. All right, so to get rid of the 3, let me go back to black, maybe that was better. Divide both sides by 3. So I have e to the x minus 2 equals 3. Once the exponential is by itself, I'm going to rewrite it as a logarithm. So I go log base e of 3 equals x minus 2. Before I go too much further, though, log base e is ln. All right, this is a good step to put in because it reminds you that you're going from an exponent to the log, log, and then if it happens to be log base e, you can rewrite it as ln. To finish solving for x, I undo subtraction with addition. Notice the plus 2 is not going inside the logarithm. It's just hanging out. Then go ahead and use your calculator. And again, this is an ln. So I'm going to use the natural log button of 3, close parenthesis, plus 2. And I get about 3.098, but 3.098 to 2 decimal places means the 9's going to bump to a 10. So 3.10 would be my approximation. Here's my exact, and then there's my approximation. For letter D, now we're given a logarithm that we need to get by itself. So the -3 has to move to the other side. So I have log base 5 of x plus 3 equals 4. Once the logarithm's by itself, we undo a logarithm as an exponent. We rewrite it as an exponent. So our exponential is going to have the base of 5, the power of 4, equals x plus 3. Right, so 5 to the 4th minus 3 equals x. And then we'll get our answer here, 5 to the 4th, and then minus 3. So 622. Kind of scrolling back up. Letter F is similar to that. We have a logarithm that we need to get by itself, so I'm going to subtract 2 from both sides. But you got to be careful because there's this minus that's coming down with the logarithm. That's like a -1 times that log. To get rid of that -1, I divide both sides by -1. And I have log x equals -3. Okay. So to get rid of that one, I need to rewrite. So it's 10, because the base is 10, to the -3 equals x. That's my exact. Now 10 to the -3 comes out 0.001. All right, well, the problem with that is if I round to 2 decimal places, it's just going to be 0.00. So in this case, our exact answer is much better than our approximation. Approximation is 0.001. If rounded to 2, it would just be 0.00. It's kind of a weird question. Right? For letter G, 10 log raised to the log base 10 of 85. So for this one, this goes back to the property. I just had a momentary brain barf here. But this is the cross-out property that we're talking about. If the bases are the same, they cross out, and we're left with whatever's inside the argument. So for this one, this is 10 raised to the log. The base isn't there, so it's assumed to be 10 of 85 equals x. So this side is going to cancel out to just 85 equals x. And that would be your answer. Letter H is similar to that. Remember, ln is log base e. So I have e to the log base e of 2x. On this side, these are the same bases. The base is e, the log base e is going to cancel out, and I'm left to 2x equals 16. And then solve for x. Divide both sides by 2. I get x equals 8.